Hello and welcome to this Abingdon Science Partnership workshop on Marvellous machines with me, Mr. Thomas. This workshop is about levers. What is a machine? We use the word machine a lot in everyday life. A machine is anything that we use to make a job easier to do. Some machines are very complicated, like my washing machine in this picture. Inside there are pulleys, gears, magnets, sensors and electronic controls, all to make doing the washing easier than it used to be. Some machines are very simple, like levers. Levers were probably one of the earliest machines humans used for building monuments like Stonehenge and pyramids in Egypt, Mexico and other places. What is a lever? These tools from my family's toolbox are levers. Levers usually have a long handle where you would push or pull, a pivot point to turn around or rest against, a part that moves the object you want to lift, hit or turn. There are 3 different types of levers which we will find out about in this workshop. First though, we have to learn some lever rules so that we can tell the difference between the 3 different types. Before we move on, have a quick think or a chat with anyone who's with you about the hammer and the spanner. Where do you hold them? Where do they rest or turn around? And what are they used to move? The hammer can be used in 2 different ways, so see if you can work them both out. Parts of a lever. The effort is made where the lever is pushed or pulled to make it turn. The pivot is the place the lever rests on or turns around. Sometimes this can be called a fulcrum if the lever is resting on it. Both words can be used. The load is the thing the lever is being used to move. So remember these 3 words and you will be ready to be able to explain how levers work. Say them this way: load, pivot, effort, and this way: effort, pivot, load, until you remember them. Or maybe until somebody asks you to be quiet. Where are the effort, pivot and load in a real lever? Here is a simple lever I made from a plank in my back garden. You will see it working in a video later. First though, can you spot the effort, pivot and load? Or load, pivot and effort if you prefer it that way. Look at the numbers. Which one is which? Did you get them right? I bet you did. Number 1 is the effort, number 2 is the pivot, and number 3 is the load. Well done! You are ready to learn a lot more about levers now. But first, why not stop the video and go to look for some levers in your home or school or wherever you are watching this. Don't go anywhere you shouldn't and don't poke around inside things. Just look and make a list. See you in a bit. Nice to see you again. How many levers did you find? Here are a few that I found. A spade, my garden shears, the handlebars of my wife's bike. Hey, I think she's going to a party without me and taking these balloons. The bell has a lever and my hosepipe reel has a lever to wind it in. What did you find? Different types of levers. If you thought a lever was a lever and that was all there was to it, you'd be wrong. They're far more interesting than that. There are 3 classes of levers and the difference between them all depends on those 3 words. I hope that you can remember them. Class 1 is when the load is on the opposite side of the pivot to the effort. Class 2 is when the load is on the same side of the pivot as the effort, but the load is nearest the pivot. This is like a wheelbarrow. Class 3 is the same as Class 2, but now the effort is nearest the pivot. What are the different classes of levers used for? Which class of lever is this? The load of 3 bricks is on one side of the pivot, and the effort, which is going to be made with 1 brick, is on the opposite side. Yes, I'm sure you knew, it's a class 1 lever. Watch the video to see how it works. Can you see that 1 brick can lift 3 bricks with this type of lever? It makes the job easier to do, so we can also call it a force magnifier. Will this lever work? Here is another class 1 lever. The effort and the load are on opposite sides of the pivot again. This time though, the effort is closer to the pivot than the load. So will it work? Watch the video to find out. I'm sure you knew that would happen. To make a force magnifier, the effort must be furthest from the pivot. Stop the video for a while and look at the list of levers you found earlier. Which ones have the load and the effort on opposite sides of the pivot? You could write class 1 next to these. Balancing with levers. Hello again. How many class 1 levers did you find? Class 1 levers can also be used to balance things. A seesaw is a class 1 lever. Watch this video to see how it works. Ta-da! What have you noticed about the length of the lever on each side of the pivot? Yes, the smaller weight of 1 brick must be placed further from the pivot than the weight of 3 bricks. Here's a good question. How much further? If you said 3 times further, you were right. Investigating levers with Dewi. This is my assistant Dewi and his dad Phil. They live in Wales and have been investigating levers. Let's watch the videos to see what Dewi found out.
Lever principle. Seesaw. Equal weights. Balance. 3 weights being lifted by 1 weight using the lever principle. The lever principle again. 3 weights being lifted by 1. The lever on my bike, the crankshaft, this bit here. It connects the front pedal to the front cog. So this is the pedal, this is the front cog. The chain connects the front cog to the rear gears here. High gears mean you go slower but can climb hills. Low gears are for going fast.
Oh, great examples of levers there, Dewi, and some great investigations. And the bike is a really good example where the pedal is a lever, but it's connected to some gears. And gears is a topic that we're going to cover in another Abingdon Science Partnership workshop. Class 2 levers. Can you remember the rule for a Class 2 lever? Yes, the load and the effort are on the same side of the pivot, but the effort is further away from the pivot. Like in this wheelbarrow, here's the pivot. The load would be what you put inside the wheelbarrow, and the effort is made here where you pull down or pull up on the handles. So the effort is further from the pivot, but the load and the effort are on the same side. Lots of tools are Class 2 levers. Wheelbarrows, shovels, spades, forks, screwdrivers, spanners, taps. Take another look at the list of levers you found and see if you can write Class 2 next to any of them before you go on to the next slide. Distance magnifying levers. The rule for Class 3 levers is that the load and the effort are on the same side of the pivot. But this time the effort is nearer the pivot than the load. Can you remember what happened in the video where one brick was nearer the pivot than the 3 bricks? I'm sure you remember that the lever wouldn't move even when I pushed down hard. This was actually a Class 1 lever with the effort nearest the pivot. But it can show us what the problem is. It would take a lot of effort to move 3 bricks, more than they weigh. This makes the job more difficult, not easier, so what's the point? Well, sometimes levers are needed to move things through large distances instead of making the effort less. These are called distance magnifying levers. Watch the video to find out more. Well, that was very exciting for that koala. I must tell you, the koala volunteered to do that because they'd never been flying before. But what you could see is that I pressed down with my foot on the short side of the plank, and the long side moved a long way and catapulted the koala into the air. That's a distance magnifying lever. Here are some examples of Class 3 levers. Your limbs, like your arms and legs, are good examples of Class 3 distance magnifying levers. The pivot is your elbow, and the muscle called the bicep, which makes the effort, is attached only just in front of it. Otherwise, you'd have a big flap of muscle and skin from your shoulder to your hand like a bat or a pterodactyl. The load would be whatever you were lifting with your hand. This is much further from the pivot, your elbow, than where the muscle is attached to the bone. This means that a small amount of movement of your muscles results in a big movement of your arm, probably so that you can pick things up and put them in your mouth. Did you find any Class 3 levers? Well, if you didn't, you can add arms and legs to your list now. Then you can write Class 3 next to them. Here's another example. It's a clock. The effort is being made right at the pivot in the middle, but that makes the load, which is the hand of the clock, big hand and the little hand, move a long way. You wouldn't be able to see the pivot moving without the hands on the clock, so you wouldn't be able to tell the time. Class 3 levers are useful after all. Anything with a dial and a pointer, like a clock, is a Class 3 lever, so maybe there are more you could add to your list. More lever challenges. If you enjoyed finding out about levers, there are a lot more things you could do or investigate that are to do with levers. Here are some ideas. Help with the housework. Some types of vacuum cleaners and brooms are levers. Or ask someone if they can show you how to use tools safely, like spanners, screwdrivers and hammers. They are all levers. If you have any construction toys, try making a seesaw like Dewi did, or a crane or a model pushchair. All of these are levers. Do a project on how levers were used in history for building things like pyramids and other big structures. Find out about levers in the human body, or even make a model of an arm like in this project at this website. The human body has all three classes of levers, which are explained here by BBC Bitesize. Have a look at my ideas about turning human arms into force magnifiers here and design a new human or an alien of your own. Here's my YouTube video. If you do any projects or make any models, let us know at Abingdon Science Partnership by sending copies, photographs or videos to me. Here's my email address. Thanks for coming to this workshop, and we look forward to seeing you again at another Abingdon Science Partnership workshop in the future.